Ever stop to think about what actually happens when you click play on a video? I mean, it feels instant, right? But that data is going on this incredible invisible journey all across the world. So let's trace that path and figure out exactly how the internet gets to your screen.
Now, to guide us through this, we're going to be leaning on the fantastic research of Dr. Sundendra S. G. His work is all about creating a clear, simple map for teachers and educators to really understand how all this stuff works. It's the perfect way to get a handle on these concepts.
So let's tackle that big question head on. You click a video. That file might be on a server thousands of miles away. How in the world does it cross continents and oceans to show up perfectly on your screen? Well, it's not magic, but it is a pretty brilliant system of addresses and rules. Okay, so the very first step in any journey is knowing where you're going, right? Before your computer can even ask for that video, it needs to find the server's exact address. And to do that, it uses something that's basically the internet's giant shared phone book.
Here's the thing. We humans, we think in names. YouTube.com, easy to remember. But computers, they don't do names. They think in numbers. Every single device on the internet has a unique numerical address called an IP address. Super precise for a machine, but pretty terrible for us to remember. So how do we bridge that gap?
That's where the domain name system, or DNS, comes in. You can think of it as a translator. Its entire job is to take the name you type, like youtube.com, look it up, and hand back the correct IP address number that the computer needs. It's just like looking up a friend's name in your contacts to get their phone number. And this lookup is actually a really clever step-by-step process. It's not just one giant book. Your computer first asks a root server, which doesn't know the answer, but it knows who to ask next. It points you to the server that handles everything ending in .com. That server points you to the one that handles youtube.com, and that's the one that finally gives you the IP address you need. It happens in a flash, and it's what makes the system so powerful. All right, we have the address, so our computer knows where to send the message. The next question is, how is it going to talk to the server? It turns out there are a couple of main conversational styles for sending data, and each one is good for different things. But first, one last little piece of the address. The IP address gets the data to the right computer, but what about the right program on that computer? I mean, you could have your web browser, a video game, and a music app all running at once. That's what ports are for. If the IP address is the street address for an apartment building, the port number is the specific apartment number. And make sure your video goes to your browser and not your game. Okay, so back to those conversational styles. On one side, you've got TCP. Think of TCP as sending a certified letter with tracking. It's all about reliability. It double checks that every single piece arrives and that they're all in the right order. This is absolutely crucial for things like a web page or an email. On the other side, you've got UDP. This is more like sending a quick postcard. It's all about speed. It just sends the data and doesn't worry too much if a little bit gets lost. That's perfect for video streaming or online gaming, where a tiny glitch is way better than a long pause. So we have the address, and we've picked the rules for our conversation. Now for the really amazing part, the actual physical journey. How does our video data literally get from that server to you? Well, a whole video file is massive. It's way too big to send in one shot. So the internet does something brilliant. It breaks that big file down into thousands of tiny little pieces called packets. Each packet gets its own address label and is sent on its way, ready to be all put back together when it arrives. And here's the wild part. These packets don't just travel in a straight line. They get passed from one specialized computer to the next, kind of like a baton in a relay race. These computers are called routers, and each handoff is called a hop. On an average trip across the internet, a single packet might make around 14 of these hops to get where it's going. The job of every single router along that path is actually pretty simple, but it is absolutely critical. It just looks at the destination IP address on the packet, checks its internal map of the internet, and says, okay, the next best step is that way, and forwards it along. They're the traffic directors of the entire internet. So we've covered addresses, communication rules, packets, routers. It's a lot of moving parts. To really see how they all fit together, let's zoom out and look at a framework that helps organize this whole journey into a few distinct layers. It's a simplified version of something called the OSI model. Now don't worry about all 7 layers, but you'll recognize the important ones we've already talked about. Way up at the top, the application layer. That's where things like DNS live. Go down a few steps to the transport layer, and that's where TCP and UDP decide on the rules. And right under that, at the network layer, you have the IP addresses and the routers doing their job. It's just a neat way to see how each task has its own place. You know, when you strip away all the incredible complexity, the entire internet really runs on just 3 fundamental ideas. You break your data into packets, you send those packets along paths decided by routers, and you manage the whole thing using protocols like TCP and UDP. Packets, paths, and protocols. That is the secret sauce. So we've just traced this invisible journey, this amazing dance of technology that happens every time you go online. But now that you know this one path, it kind of makes you wonder, doesn't it? What other hidden journeys, what other invisible systems are working all around us right now to power our digital lives?